Okay, so here I have a set. I want you to find a basis and find the dimensions for this subspace that's spanned by this set of vectors. So first off, I need to go find what the basis is of this set of vectors. So the basis will be the set of vectors that span. So I can see I can pull an S out and then pull a T out. So I can see that this set, they didn't even give it a name, but this set will be, the basis for this set, let's call it B, will be 4, -2, 0, 0, 0, 1. So this would be the basis for this set of vectors. So, oh, here I have it right here. Sorry, I forgot about that. So these two vectors form a basis for this subspace spanned by these two vectors, and since there's two vectors in here, the dimension is 2. So if I have H as a subspace of some V, so V is the outside one and H is some subspace in here, the dimension of this will always be smaller than the dimension of this, smaller than or equal to. So if I've got a p-dimensional vector space, so what does a dimension mean? Number of vectors in the basis. So if I know that there's a certain number, p has to be bigger than or equal to 1, at least 1, right? Then any linearly independent set, oh goodness, look at all the typos, of exactly p elements will automatically be a basis. So if I have P, if I know the basis has it's three-dimensional, then if I pick 3 linearly independent vectors, then they will form a basis. So we just have to find the right number of elements, the right number of vectors that are linearly independent or spans the space, and it's going to give you the set of vectors that will be the basis. So let's talk dimension. Dimension of null A is the number of free variables, right? Because that's how I get the vectors. So remember, it's lots of work to find the basis for null A. The dimension of the column A is going to be the number of pivot columns. That's not going to be much work. You just need to find the reduced form, and then you can find the dimension, because you can easily find the pivots. All right, so let's look at these two matrices. So they're in echelon form already, but echelon form gives me where the pivots are, right? So this is a pivot, pivot, pivot. So I have 3 pivot columns. So I can see that the dimension of column A will be 3, because there's 3 pivot columns. All right, because I see 1, 2, 3, 4, 5, that means if I was to multiply times something, an x, right, the x would be 1, 2, 3, 4, 5, right? That was very messy, sorry about that. But this is a 3 by 5 matrix. So 1, 2, 3, 4, 5. So you would have 5 entries in this X, right? So that means that dimension of null A, right? How many free variables would I have from this matrix, right? Out of 5 total, how many free variables would I have? Well, I see I have 3 basic variables. And so that must be, so since there's 3 basic variables and I know there's 5 total, that must mean 2 free variables. So that means the dimension of null A must be 2. One last one here. So if this is the matrix, so I can see there's 3 pivot columns. So the dimension of column A will be 3. So if I'm solving this to find out, augmenting it, right, with zeros, AX equals 0, if I'm solving that, how many free variables would I have? Well, none. So that means the dimension of null A is 0.